Yeah, it's coming. Uh, in your test, there was one function which is finding NCR value. So yesterday I have given you some recursion, but just reading, we gave the answer. So it comes into that category. You don't have to trace, but you should confirm that the steps are perfect. Then you can recursively you can find out that NCR. I have not covered it because I am just focusing on simple recursions along with that static variable and global variable only. That part only I have covered. So I have not started that part. And so that they have given the question anyway. But you don't have to trace it. From the question you can understand, means from the code you can understand it is doing this. So yesterday some 2-3 questions we have done like that. So there are a few more questions, not based on recursion, using loops and all. Just by looking at the code, you can say this code is doing this. Okay. So now let us start. Uh, uh, I will discuss about it and let you know for WhatsApp group or Telegram group. Huh. So let us start with the topic. So we have we have learned recursion, we solve few recursions. Okay. Now the next thing is, next topic will start. See pointers, then functions, arrays, structures, loops, operators. So operators, I may not be covering it as a separate topic, all operators and all. In between, whenever we come across something, I will include that because basic thing, addition, subtraction, all these things. Precedence is important in that one. Increment, decrement is important. So we'll come across that one. So anyway, I will cover it because bitwise operations I have to show you finally. So, but very few questions are there on that. So more number of questions are here. So I have started in this direction. All right. So if I start with just operators, then I will be giving 1 or 2 questions only. Otherwise, my own created questions I will be giving. So that's why I have started with recursion. So you have done enough number of questions. A lot of questions you have done yesterday. So you have entered the topic. Now let us start. There are a lot of questions using pointers. Using pointers. So now we are going to understand what are pointers, and mainly we will learn what is the syntax. So more focus is on syntax in this topic because the concept is little bit only. So syntax is more important. And the next important thing is its usage. What is the use of pointer? All right. So let us start. So don't start copying. And one more thing, whenever I'm writing on the board, don't copy anything. So when I give a gap, when I pause, then only you take down. I'll tell you, you note down it. Because while writing also, I'll explain. Okay. So yeah. In that way, we'll have some pauses also in the class. Otherwise, continuously speaking and listening, you can't grasp everything. So just watch, let me explain. When I say take it, then only you take it. Okay, let us start. See, usually we declare the variables like this. Suppose integer a assigned 10, or you may be declaring a variable, or I'll do it here. You may be declaring a variable like float b assigned 1.5 f, something like this. So variables, and variables will have values assigned to them. Those values are called as constants or literals. You know this. So these variables are storing what? Data. Data. So these type of variables are called as data variables. Data variables. All right. Now, next thing is, if you talk about memory, if you talk about memory, in the memory, these variables will be created. These variables will be created. Yes. And you know that every memory location is having its own address. So we access the data in the memory using its name, A, B, in our program. So is it possible that we access the data using its address? Yes, using the address also you can access the data. When you said int a assign 10, the value 10 is stored in the memory, and in your program, whenever you say a, you are referring to this one. So we access the data in our program using variable name. Now, question is, can you access it using the address of the data also? Yes. So for that, we need address variables, which will not store data, but will store address. So next is address variable. Now, I want to declare one variable of integer type and name is p. Now, is it a data variable or address variable? Data variable. So there should be some difference or different distinction in between data variable and address variable. So for that, the syntax is star. This is called as address variable. This is called as address variable. The one who is knowing the address and showing the address is called as pointer. So pointer is a term used in C language. Actually, it should be called as address variable. Address variable. A variable which stores address. What it is doing, it's pointing. So they gave the fancy name as a pointer to it. All right, got it. So, or can you say reference also? Ah. So if it's storing address, you can say it's referring to that location. Reference also you can say. So that are general terms. But actually, if you talk in terms of what the variable is doing, then you should say it's an address variable. So address variables in C language are called as pointers. All right. So how to declare address variable is star. Now, let us start with the syntax. I'll remove this one. You don't have to take this, right? So I have removed this one. Now, suppose you have declared a variable a and it is having value 10, then another variable you have declared and that is a p. This is a data variable, this is a pointer variable. I'm showing the syntax. What is the meaning of each line I'm showing you? Then this is called, next is, sorry, p assign ampersand a. P assign ampersand a. So what does it mean? So for that, let us draw this memory here and let us think that this is a program and you know that activation record is created. This is A and this is P. Suppose this is inside main, okay? So you will get an activation record for main. So where these two variables will be created? Inside the activation record. A is a variable. P is a no, okay, just variable. Both the variables are created there only. Now assume that the address of this location is 1000 and this is 1002. So when you say p assign ampersand, this is having value 10. When you say p assign ampersand a, so this will be storing the address 1000. So it means it is referring to this one. So we are assigning the address of a to p. So p is holding the address of a now. Then next, suppose if I say print, I'm not writing printf percentile d everything, just a pseudocode. So a, then what will be printed? 10 will be printed. You know well. Now, watch. If I say P, when you say A, its value. When you say P, its value. So you'll get what? 1000. When you say print star p 10. Acha, if you want to print this one, print ampersand a, what do you get? 1000. And same way, if you say print, there is no space, just trying to write here itself, ampersand p, then 1002. All right. So once again, repeating the points, pointer variables are nothing but address variable. They are used for storing the address. So if this is a main function in which I have declared one data variable, one pointer variable. So if you see this one, this line is declaration of address variable. This is how it is declared. It is declared along with asterisk, asterisk. Then it should store the address of something. So I have given the address of A. So this is called as initialization of this one. Then after that, I am printing. So print A, print, you know what is happening here. So in this line, we are using star p means it will go to the address and access the data. It will go to that address and access the data. So this is called as dereferencing. This is called as dereferencing. Now, let me finish. One more thing. When you say A, you have its own value. When you say P, you have its own value. That's an address. You have to use percentile U here for printing that one. Okay, not D. U. U means unsigned integer. Addresses are unsigned integer. I told you this one. So percentile U have to say for printing the address. Now here, when you say print star P means what? We don't want the address. We want the data present at that address. So go there and get the data. So when you are accessing with star P, are you directly accessing a value 10 or indirectly accessing? Indirectly. So pointers are useful for accessing the data indirectly. Pointers are storing the address and they will access the data indirectly. 2 points. Now one last important thing, this one. And okay, when you say ampersand A, you have the address of A. Okay, one more thing. When you say ampersand P, you will get the address of the pointer because pointer is also a variable. Every variable is having an address, so pointer is also having its address. So when you say ampersand P, you will get the address of that same variable. All right. Now, syntactically, the important point. Syntactically, this is which line? So I should write star. This is which line? Dereferencing means go there and get the data. So for that also you have to write star. Here, initialization. So you don't have to write star there. You don't have to write star there. When declaring, write star. Dereferencing, write star. But when you are dealing with the address inside the pointer, you don't have to write star there. Understood this one? Star means data. Without star means address. So what you are doing here, you are storing the address of a variable. So you don't have to write star. So this is the one important thing that should, when you're reading the code, you should clearly know what is happening in this line. Okay. So the syntax, this is important. All right. Now you can note down and see what is happening here. You can take all these things. First printf percentile D. Second one percentile U is better. D also it works. It is possible. It may be possible. But with the D, it is having its range, negative to positive. So if it goes beyond, don't know what it will print. But you may not get error from the compiler. It will not say that, no, not percentile D, you should give some other. It will not give error for control codes. But output you may not get perfect. Syntax. No, syntax. Syntax error. Syntax error. It may be a syntax error. Try that one. Because it is an integer type, but you are trying to store means unsigned int value. Unsigned int value. P means this one. Star means take the address and go there and get the data. Okay, P means 1000. Star P means the data at 1000. Data at 1000. Over. Next. So, what is a pointer and its syntax? Over. Just two things we learned. Now, oh, okay, I'll write here only. What is the use of pointer? Why you need a pointer? All right. Why you need a pointer? So for gate or C language purpose, it's little limited. Okay. But I'll try to give you the complete picture on this one. Complete picture. Why you need a pointer in C programming? Acha, what is the toughest part in programming in C, C++? Pointers only. Pointers only. Because the problem with the syntax there. What is happening there? You may confuse. And if you write it and run it, then it may cause problem also. It may cause problems. All right. So it's a difficult part, but that is very important. Without pointers, you cannot do anything. So let us understand what is the use of pointers. So for that, I'll take a new slide only and explain. Uses of pointers. First one, dynamic memory allocation. I'm just listing them. I'm not explaining. Okay. Then second one is parameter passing. Parameter passing. And third thing, I'm just adding it. In C language, it also in C, C++ also support pointer arithmetic also. Okay. So indirectly, these are becoming our topics also. Three topics also. Then fourth point, important thing is pointers are useful for accessing resources. So this is the general idea with which I'll give you what is the use of pointer. So you'll understand what is the importance of pointer. All right. But no question on in gate based on what is the use of pointer. The questions are on these things: memory location, parameter passing, and this one. These are the things that you have to thoroughly understand. Now, I'll give you the general idea what a pointer is. Watch this. What is the use of pointer? See, this is random access memory, right? This is random access memory, and this is the code section in which your program resides. And this is the stack. And one more portion is called as what? Heap. One more portion is heap. Now, when a program is running here in main memory, then what is its own region, program's region, or its territory, its own territory? Only this much. Code section and stack, code section and stack. That is the territory of a program. So from the first class onwards, I am showing you heap there, but I have not shown you what is the use of heap, right? How to access, I have not shown you at all, because it's not a part of a, that is the main territory of a program. It's an outside resource for a program. Though program uses it, that's a, that is useful for the program, but it will not use it as its own. For example, little small example I'll tell you. See, this is a classroom. Can you go into that classroom also? Huh. But that is not your classroom. All right. Can you go into the office room? But that is not your space. So you can knock and take a permission and go there. But so actual space is your actually this is your space, right? So this is your domain or this is your territory. You can say you can sit anywhere whenever you come, wherever you want, feel comfortable. You can sit there. So even for me also, I am having this territory. This is a classroom. I cannot enter into that classroom. All right. So if its class is going on, I cannot go there, or it's useless for me. So in the same way, program will have its own space that is actually called as context. Now listen carefully. There's a little bit long story behind this one. This is called as context. Now, program can directly access the memory which is within its own context. Program can directly access the memory which is there in its own context. So in the previous picture, you have seen that this is inside the activation record of a program. So it can directly access these two variables, A and P. No doubt P is an address variable, but it's a variable that is in the activation record. It can directly access only the memory which is present inside. Yeah, yeah. अच्छा ठीक है आप बता दो मैं दे दूंगा फिर. So it can access the memory inside code section, memory inside stack directly. Directly. Then how it can access the memory inside heap? From the beginning, I am saying that it will divide the memory into 3, 4 sections and use them like this, like this. Then how it will access that memory from the heap? It will not access directly. It will access this memory indirectly. Indirectly. No, wait a minute, wait a minute. It will access the memory indirectly. All right. Now, let us take an example. Let us take an example. Suppose we have a library and you want to take a book. So will you directly go and pick up the book, or you will ask the librarian to give the book? Okay, he will give you, okay, this book is given to him on so and so date and so time. Sign it here. You will pick up the book, you will use it. And again, when you have finished reading, when you have finished your work, you will return it back, and he will also mention there, he will note down that he has written the book on so and so date and time, sign. Right? So in a college, let us take the example of a college. You want something, sports kit, cricket kit or football or something you want to play. You go to the sports room, you will borrow it, you will sign and everything, and it's taken. And again, you have to return it back. Though it belongs to students only. But in the classroom, for sitting there, you don't have to go and take a permission and sit there. That is your own domain. But football or cricket sports things also belongs to you. Library also belongs to you. But you have to take a permission and use it. And the systems in the lab, computers in the lab, when your lab is going on, it's okay. Otherwise, you should take a permission. Can I use the lab? Yes. Make an entry in the log. I am using this so and so machine from so and so time. So actually, those are not your direct, that doesn't come into your direct context. So whatever doesn't come to your direct context is actually called as resource. It's called as resource. So resources are requested and taken. When finish using, they should be return. Now keep this in mind always. This will help you in this subject and all other subjects also. Okay. Resources means request and take it. When finish using, return it back. So this should be the discipline followed when you are using the resources. Now for a program, what are the resources? Let us look at a file on the hard disk. You agree? Network connection. You agree network connection is a resource or not? Outside thing, it's not a part of a program. And peripherals like printer, peripherals like display monitor, right? Got it? So all these things are outside things for a program. And for accessing outside thing, it cannot access them directly. It should request and use them, and finish using, it should release them. All these are resources. So the heap memory also comes under resources. Heap memory also comes under resources. Understood those? So what I have explained you, I have explained you what comes under the context of a program and what is outside the program. Whatever is there outside the program, that is called as a resource. Okay, what that is called as a resource. All right. Listen, I'll give you an example. One more analogy I'll give you. You have your own car. So you have a key, you can park it anywhere, you can use it anytime, wherever you want, you can go it. That's your own car. Now, that is within your context. Uber cab, is it your own? It's like a resource. Whenever you want, you book it. Now the driver and the cab is assigned to you from this trip location to this location. Now, as long as the trip is going on, it's your car. As long as the trip is going on, it's your car. In your app, that car or cab is attached, finished, it is removed. It's like a resource. Attached and remove. So for attaching and removing, it's not direct, it's indirect. So same way, when your program want to reuse these resources, it should connect, attach, or request and take it and use it and release it, use it and release it. So for doing this, you need pointer. You need pointer. So in C++, pointers are useful for accessing all the resources. In the resources, what is also included? Heap is also included in the resources. Heap is used as a resource. Is it clear now? Idea is clear? Acha, have you ever written a C program for opening a file? I know, yes, you have written it. I'll just, to help you recall that, I'll show you that. You have written it like this. File. Yes or no? In C, have you opened any file or not? No. File handling, have you done in C language? How do you open a file? File, start, which one? Which function? Acha, okay, you don't remember it. Are you able to recall this? File star FP. Those who have done it, because this is usually in your academics, you will do it at the end of the semester. So some people will do it, some don't do it. But if they are doing some project, then they may come across this one. Anyway, file star FP. Why star? FP is a file pointer, opening a file, for opening a file. Why star? It's a pointer. For accessing a file, you need a pointer. And if you have done any socket programming, you might have seen this socket star ST. Socket means network connection. You have to say ST for socket. Actually, it's a name convention use. But star, why star? It's a pointer. So for accessing all the resources, you need a pointer. That's all. So what is the actual use of pointer is for accessing resources. So the last point is important that I have explained you. Now these things we will learn them slowly, because from heap we have to discuss more on this one. This is a general idea, general discussion I told you. All right. So tell me, can you develop applications without pointer? You can't access file, you can't access network connection, you can't access printer, you can't access monitor. No doubt printf and scanf will help you to do that. But without that also, you can access them using pointers. So leave these two. Other resources, again, you need a pointer. You have a camera, you have a mic, all those things you want to access, then you need a pointer definitely. So for all the resources, you need a pointer. So without that, you can't develop a good application. So pointers are must. And majorly, heap you cannot access without pointer. So pointer is must. So whatever you want to note down, you can note down this one. So I have explained about the last point. Now these points, we will learn them slowly one by one. Honey, that's the next thing. Next, new is not a pointer. When you declare any variable with star in front, that is a pointer. Whatever the data type may be, data type is not important. File is the data structure here, actually structure in C language. So let us say data type. Star means pointer. Socket is a structure. Star means pointer. So whenever you declare variable of any type by using star, then it's a pointer. It's a pointer variable or address variable. Now new malloc, that is a different thing. We'll come across that. To sum up this, all these are resources. Heap is also a resource. Only code section and stack come under the context of a program. All other resources are accessed using pointer only. So without pointer, you cannot access any of these resources. Hmm. Okay. In Java, there is pointer. In Python, it's not. In Java, also references are there. Python is full of pointers. Okay, I'll discuss about that. I'll discuss. Okay. So I have started with address variable. Okay. Later I said it's a pointer. Finish this one. Now let us move to the next slide. All right. Next slide. Now listen. Anyway, you may be having a doubt that in Java there are no pointers. Then how it is possible? In Python there are no pointers. Then how it is possible? All right. So listen, just answering that question. Answering that question. So in C, C++, you have pointers. Okay. Okay. I should be on the same slide. No, there is no space. I'll write here. There's no space. See, in Java, if you are saying integer a assigned 10, what is this? Data variable. Data variable. You're right. Data variable. When you say string s assign hello, what do you call to this s? Then what do you call to this s? Which type it is in C Java? This is called as variable in Java. Okay. This is called as a reference in Java. And it will create a string. It will create a string object. Are you aware of Java or not? Little bit. It will create a string object. So S is a reference. S is a reference. So what is this reference? Address variable only. They are calling it as reference. Sir, there is no star. That's a Java syntax. Normal variables, integer, float, double, short, byte, long, data variables. String, string buffer, or buffer reader, or file input stream, file output stream. For everything, all these things, what you will be creating? You will be creating objects. Array, you will be creating objects. For objects, they have references. For object reference, what is this reference? Address variable only. But they have remove star. And they said that It's address variable. They have not used the same name as pointer, and they have changed the name and said that it's a reference. It's not a pointer. Java is not having a pointer, but Java is having address variable or not. See, I'll show you one more thing. Here in Java, you write string s1 assign new string hello. This is a reference. This is a reference holding an object. So that is called as address variable only. All right, address variable only. They have removed star. Now, the magic was like this. The benefit was like this. I have studied actually Pascal. C was not common at that time when I was a student. Then C started becoming famous and commonly used, so I studied C. So I then again C++. So I learned C++ after studies. So in C++, I have pointer. It's a headache for me for accessing resource star, miss the star, something problems are there. So when Java came, oh, it's happy. There is no pointer. Actually, they made the syntax simple. Right? If they have used the same name pointer, then I will try to use it like a pointer only. They said that there is no pointer. This is just a reference. Just 2 minutes, 2 minutes. They said that there is no pointers. But reality is it's having pointer address variable. Address variable. So if you want to see this, actually hello is stored here. Okay. Hello is stored here. S1 is a reference to this. We draw like this. If you have learned Java, you draw it like this picture. Do you remember? So why this one then? It's a reference, address variable, address variable. Acha, in Python, direct, there is no data type, nothing. You can write like this. You can directly say like this. X assigned 10. But no book gives you a picture of this variable. They show it like this. They show it like this. No. Actual picture is this is the picture. Every variable you declare is a reference. So in Python, there is nothing like data variables. There is nothing like data variable. All are, no, don't say pointer. Address variable, address variable. So remove address variables. All are address variables only. Data is stored somewhere, variable is somewhere else, and it is referring to that one in Python. But no book will show you that one because without that, it's not possible in Python. Without reference, it's not possible at all. Okay, this is enough. So actually the question was like, I thought you got a doubt that, but Java is not having. You are saying resources you can access only using pointer. Java is not having pointers. Then how resources are accessed? So I just showed that Java is also having address variable. Python is also having address variable. But we don't call them as pointers. That's all. In Python, we say variable. See, it is just like when you go and order a meal in hotel, when it is coming on your table, just to start having it. You will not ask what is the oil use, what is the type of rice used, from where you bought the rice. No. So, aam khao, ped mat gino. There is a Hindi saying, right? Gutliyan mat gino. So, aam khao, acha, itne ped hain inke paas, wo mat gino. आम मिल रहे हैं ना खा लो if somebody is giving you more and more mangoes, oh, how many gardens he may be having, mango gardens he may be having. So don't count that. That's the meaning. You are getting mangoes, you have them. So when you eat, you are not concerned about that. So Java also says that aam khao, ped mat gino. Gutliyan mat gino. Aam khao, gutli mat gino. Means just you focus on what you want. Don't see it's a data variable. That is, C language says that, no, you cook it and eat. You go and give an order in hotel. So, sir, we don't serve. You have to cook it. We have all the things available here. So, C. So, who is more powerful? C is more powerful because you can cook the way you want. That's enough. That's enough. Actually, this is going just a general discussion. Entire thing was general discussion. Now, let us go further. Now, let us come to the next thing. I'm going to discuss something. Then you can note down. Okay? Important thing. Listen. After that, I'll give the heading. When I say integer a assign 10, this is main memory. This is the code section. Let us say this is a main function is present here. I will write inside main. Okay, watch this, watch this. This is stack and this is heap. When you say a assign 10, this is the activation record of main. So you'll get the memory for variable a in stack activation record in stack. Okay, then if you say b assign 1.5f, then you said integer star p, no initialization. Where? Same place only. Whenever you declare any variable in your program, the memory for that variable is allocated in stack in the code section, sorry, activation record only, right? Declaration is done. Now watch, now watch. If I say p assign, it's a pointer, new int of size 5. I'm not using C syntax here. I'm using C++ syntax, which is allowed in latest version of C also. P assign new int of 5, I said. So are you aware of this line? So what I am saying, I want 5 integers. 5 integers. So it means I want an array of 5 size. Array of 5 size. Where? Where you want? New. I want it in heap. I want it in heap. Whenever you say new, memory will be allocated in heap. When you declare normal variable, stack. When you say new, memory is allocated in heap. New means memory in heap. Is it clear? Understood this one? When you say new, memory is allocated in heap. And you should mention how much memory you want. So in C++, you can say, I want 5 integers like this. Okay. How to do it in C, I'll show it in next line. But this is simple. So you understand what is new first. So new int. Then listen. What is the address of this A? Let us say 1000. What is the address of this B? Let us say 1002. What is the address of P? Let us say 1004. Now, I want to access A. Okay, use the name A. You don't need address. I want to access B. Okay, use the name B. You can access. I want to access P. Okay, use the name P. You can access. Now, I want memory in heap. Its addresses are, suppose, 3000, 3002, and 3004, 3006, and 3008. Now, the question is, who will access that? Is it having a name? Is it having a name? No. Then how do you access? Not with name, by its address. Then you should have somebody to hold the address. Where? You need somebody to hold the address within the context of a program. So do you have somebody already available here? Yes. Who is that? P. So yes, it will have this 3000 and it will be referring to this. All right. So now you got the clear picture. What is the use of the pointer? So pointer is used for accessing resources. Among that, leave all the resources. We are discussing about heap now. So, but how to get the memory in heap? How to say that? New. But whenever you say new, memory is created in heap. All right. So now see, if you are declaring normal variable, it is in the stack. If you say new, memory is in heap. When you are getting memory in heap, you will get the address. And for that, you need a pointer which will hold the address. You need a pointer to it. It will store the address. All right. Now, lastly, your program, can it access directly value 10? Directly value 10? Yes. Can it access directly value 1.5? Yes. Can it store directly value here? No. It will be doing it indirectly. How? First go on P, take the address and go there, and then write down if it has to write down any value here. Let us say 4, 3, 9, 7, 8, anything, whatever it want, it can store it like that. So it can read and write the values there by using P. So heap memory, is it accessed directly or indirectly? Indirectly, because it's a resource. It's a resource. Now, once again, normal variables in the stack. Even pointers also inside the stack. But when you want memory in heap, you must say new. All right. Now, one last thing. Okay, I have to write down some more. Okay, don't start writing, just listen. In Java, for everything you write new, new, new many times. So it means everything you are creating in. So heap cannot be accessed directly. So when you are saying it's a reference, it's not a reference. So it's not. Is it not a pointer? Is it not an address variable? When you're saying S is a reference, is string is created where? In the heap. You know this one, right? Objects are created in heap. When you say new, it's created in heap. So S is referring to that object. So it's nothing but a pointer only as per C language, or it's an address variable only. But in Java, they say that it's a reference. Because in Java, you cannot say print S1. Print S1 means, okay, go there and print hello. No, no, I want the address inside that. What you will do with that address? S1 means data. Okay, see the data. But in C language, when you say just P 1000. No, no, I want data star P. Okay, take the data. So you have both the syntax. You have both the syntax. Understood? Are you getting me? Same way, I brought mango to you. Where do you have a farm? Why do you want farm address? You want mango, take the mangoes, that's all. So when you say S1, take hello. Why do you want address? So Java doesn't allow you to involve in addresses, but it uses addresses. In Python, you don't have to say new also. It will create in the heap only. Every variable is created in heap in Python. Understood? Got the clear idea now? So coming back to this picture, yeah. So now what I have explained you is how you allocate the memory in heap by you have to say new. And the other syntax that is used in C language is watch this one. You have to say P. Watch, I'm explaining and writing. I'm not writing the prototype, I'm writing example. Function name is malloc or malloc, memory allocation. So this is a function. Listen carefully. This function will allocate the memory in heap. So it wants how many bytes you want. It will not ask integer, it will not ask float, it will not ask anything. It is concerned about number of bytes you want. Okay, I want memory in heap. How many bytes? All right. So it will not say, do you want to store integers? Do you want to store float? Then as a programmer will say, why do you want that, all those things? Just give us bytes, that's all. We will use as we want. So we are more powerful here in C programming. So we'll just mention how many bytes you want. So tell me how many bytes you want. 5 integers. So not 5. 5 into 2. 2. But in C language, some platforms it is 2 bytes, some platform it is 4 bytes. So that's why this practice is there. That's why this practice is there. So we say what? Size of, in bracket, we will say integer. So wherever you compile, it will take the size of that integer on that particular platform into 5. So if it is 2 byte, 5 to 10. If it is 4 byte, 20. Now, malloc. Listen. Malloc did not ask you want for integer. We said size of. Actually, we were not aware what's the size. Otherwise, you can write 2, 5 into 2. It will not ask you anything. It doesn't know what type of you are using. Acha, is you can directly ask 20 also, 10 also. It doesn't know what you want. Okay, just these many bytes. Okay, these many bytes are given. Now, when you're taking it in the pointer, it's what type? Integer type. So you have to typecast it and take it. So you have to write integer star. Why? Because malloc actually returns void type of pointer. It returns void type of pointer and it takes size here. I'm writing the syntax. It takes size, return void type of pointer. That's why it should typecast the pointer and take it. Typecast the point. Understood? So in C language, you have the syntax like this. Now you tell me this is easy to read or this is easy to read. First or second? First. So in old C programs, in old C means previous papers, you find malloc is used. Later on, they started using new only now. But anytime they can write malloc, you should know about malloc also. So they are using new. In the latest questions, they started using new for allocating memory in heap. Okay. So to wind up, normal variables in the stack. When you get the memory in heap, only if you say new or malloc. Malloc. New or malloc. And when the memory is allocated, the address must be taken in. The address must be taken in. No, no, no. Huh. Address variable. Address variable. Or pointer. 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 Only two things I have explained you. Uh, Upra Keshav, that's a different topic. I'll be covering it. If one pointer point to another pointer, that's a different topic. Slowly we'll move there also. Okay. So man, okay, that's fine. You are following. That's great. Hope you are enjoying the course. What does the int int star means? No, that is just a syntax. Star means just a syntax. They have used the syntax. There should be some difference, right? There should be some distinction between normal variable and a pointer variable. So developers of C language thought that let us give star there. Yes. I have to give a break. Little bit break. We'll take 5 minutes break. Online students. Huh. So next thing, I'm just writing the syntax. Just watch. Huh. If I say p assign new int of size 5, then the memory for 5 integers, depending on the size of the integers, maybe 10 bytes or maybe 20 bytes will be allocated there. And p will be pointing to that. And I have given the addresses, small addresses there. That is 200 I have taken there. So this will be having the address 200. This will be having the address 200. All right. So what we learned just now is allocating the memory in heap. We have seen it. Now the question is how you can access that memory in the heap. So watch here. I'm showing you the syntax how to access the memory in the heap. P of 0 assign 5. P of 1 assign 8. P of 2 assign 9. P of 3 assign 10. P of 4 assign 6. I'm accessing as if it's an array. And P is the name of an array. And I don't have to write stars or anything. So by allocating the memory in a heap, just at the time of declaration, you have to use a star. After that, you can use it just like a normal array. And if you want to print anything, you can print also. You can say print P of 1. The value that will be printed is 8. And one more thing. If I say star P, then assign 15. What happens? P of 0 will be made as, because it's having whose address? Only first byte address. First byte address. All right? First byte address. Only the beginning address it's having, a base address it's having. Beginning or base address it's having. Then by using subscript 2, subscript 3, subscript 4, I'm able to access the memory beyond the base address. So it will go there and access the data. All right. So it will go 3 integers ahead and get the data or assign the data. All right. 1 integer ahead and get the data. So by using subscript operator, you can access the entire array. So you can note down. So what is this? Accessing the heap memory. Accessing the heap memory. So you can access it just like a normal array. Normal array. You will get just the base address. Base address. Yes, Varun, when you say new, then it is created in heap. Just a star will not make sure you are accessing heap. All right, over. So I have just shown you how to allocate the memory in heap, but related to allocating heap memory also, there are more things that you have to learn. Just we are going to discuss that now. Next. All right. Next important thing. So I will change the slide and discuss. See, this is your program. In this, you have taken a pointer and you said that p assign new int of size 5. All right. Then you have used that heap memory. Now you don't need the heap memory. Then you should say delete p, or you should also say free p in C language. Free p, either this or this syntax. So just now when I was explaining about resources, I said that when you want resource, you have to request and take it. So you are requesting and taking it. And when you don't want them, you have finished using the resource, then you should return it back. You should return it back. So whenever you allocate heap memory, you should also make sure that you are releasing the memory. Releasing the memory. Now one doubt. This is in the main function. I have allocated the memory. The program will finish, then automatically deleted. Automatically deleted. So no need of deletion. But it's a good practice that you delete, because if it is not a main function, some other function has done it, then that function is ending now. So who is responsible? Who has taken that heap memory? Function fun has taken it. So when it has finished, function fun should release the memory. It's a good practice. All right, now watch here. I'll write on the code here. Function fun integer star p. Okay. Then at some point it has said that I want integer of size 5. Then after that again it has said that to that same p I want a array bigger than that one. At some after some point it said that no, now I want a smaller size memory of array size, that is 3 only. That is enough for me. Now, if you read the code, function fun in your program has allocated the array of size 5, then did something, then assign an array of size 10, then did something, then assign an array of size 3. Is it deleting anywhere? No. So what happens? Just watch. Just watch. So somewhere in the stack, activation record of this function p has created an array of size 5. Then after that, it has allocated array of size 10. 1, 2, 3, 4, 5, 6, 7, 8, 9. So now it is no more pointing on this one, right? Sorry, it's no more pointing on this one. It's not pointing on this one. Then after that, it has created an array of a size smaller than that, 1, 2, 3. So it's right now pointing here. So it's no more pointing here. So right now, presently, P is pointing on which array size of size 3. Now, what has happened to array of size 5 and array of size 10? Program has not finished. Program has not finished. Does it still belong to the program, or it is taken away? Still belongs to the program. Still belongs to the program. So I'll give you an analogy to understand this one. I am a sports in charge. I am in the sports room, right? Somebody from your class came and said that we are playing football. I want a football. We want a football. I have given it, taken into the register. Now, in my record, football is taken by one of the student. He is playing in the ground and he left the ball there only. Then he forgot where he left. Then, oh, I need a football. He again came to me. One more football. He played and went for a drink or some break, and then football, we want to play football. Again he came. So I'm not asking that you have taken a football just now. That is not my job. When a student comes and asks for a football, I'll give a football to him. That's it. I'll take a record and give a football. All right. Understood this one. So total four footballs were there in the sports room. All football are in the ground, and even you don't remember where you left them. You forgot, you took a break. See, just now I took a break. Suppose I forgot I was taking a class, I will directly go home. We'll be sitting here only. As a break, I went out. Suppose I forgot what I was doing. Ah, I should go home. I will go home. So it is just like that only. You forgot, now. You forgot this address. You forgot. You don't have the address now. You only remember this one. So what about those two? In our records, it's there with you only. Are you getting me? So what happens? Slowly, one ball is going away from the sports room. At one stage, if you again come, I want football. There is no football. So all the footballs are leaked from the storeroom. Now even I did not get it back, and even you don't remember. Is the person who has taken it is not responsible now. He don't remember. CP, what was the address of the array of size 5? No, I don't remember. I know only this address right now. 3's address. It's overwritten now. So even he don't remember. In my record, it's there with the program. Now if you come and ask more memory, I don't have the memory. So slowly it's a leakage of the memory. It's just like leakage in a bucket. You are carrying the water and it is leaking. By the time you reach home or your destination, the all water is gone. So it's leakage. Leakage. So this is called as leakage, means it doesn't belong to anybody. We have not used it. Anywhere it's not there in the resource, in the well now. Not even in the well or in the pot or tank, and not even used. So it is wasted. So this process is called as memory leak. Memory leak. I have explained you about memory leak. All right. So I have explained you what is heap, how to get the memory in the heap, and how to access it just like an array. Right. More we have to study that. But along with this one important thing was whenever you are allocating heap memory, your program should release it. If it is not releasing, then it's there with the program only. Now suppose function end. Program is not ending. Program is not ending. Function ends. Function end means who allocated this one? Activation record is gone. So you don't have the record for all those three memory. It thinks that it belongs to the program only. Understood? Now one more thing, one more thing, one more thing, one more thing. The memory inside the activation record belongs to, I want to answer, quick answer. The memory inside the activation record belongs to a particular function. Very good, very good, very good. Understood this one? Either for the main function or function 1, function 2, A function, B function, some function. Memory in the heap belongs to program, entire program. Whichever function allocate, actually it is given to the program, not to the function. Understood? Understood this one? Got this? Now one more thing. If this function is sharing the address of that memory to another function, can it access that heap? Yes, yes, it can access the heap. So the heap memory belongs to the entire program, and any function can access that memory if it is having its address. So whoever created should share the address. They can access it. Others can access it. So we are not looking at that scenario, but just I told you this one. Okay. So once again, memory inside the activation record belongs to the program function only, but memory inside the heap belongs to entire program. How long it remains in the heap? As long as the program is running. Understood? So anyway, sir, program ends, it will go away now. What's a big problem? So now you tell me, in your laptop, from how many days you have not closed Chrome? Open, it's running. Hibernated. Open, it's running. You have not closed it. Chrome, Safari, browser, any browser. You are using it more frequently. On my machine, it's open from last 2 years. Chrome browser, Safari browser. Anyway, when update come, it will restart. So ignore that. So or past 1 month, it's up. So many pages I have open and close, open and close. So when I'm opening a tab, it may be acquiring heap memory for storing the data from the page content. It may be taking that, keeping them in the heap memory. When I close the tab, that should be deleted. Otherwise, if I open and close few tab after that, Safari browser will crash because there is no memory, heap memory now. And even all the program will crash because it has taken the heap memory irresponsibly. It has not returned it. Then the memory is not there for other applications also. Understood this one? So it's like a responsibility of a programmer who has written the code. When he is saying new in that same thing, when he has finished using, he must say delete also. That is must. That is must. Understood this one? So whatever you have understood, you can write on. The points I will repeat. Whenever you allocate the heap memory, you must release it, right? Because it's a resource. If you don't release, it stays with the program because the heap memory belongs to the program, stack memory belongs to the function. It remains in the heap memory as long as it's running. If you're not releasing the memory like this, then it may cause memory leak. At one stage, the program will crash. That's all. These are the points. Heap memory should be released. If not released, it's leak. Leakage called crashing of a program. Rename. Achha, why one variable is used for multiple time allocations? Huh? No, at one stage, I was in the requirement of 5 integers. Later, I wanted 10. I made it larger. Then I want smaller. It's not renaming, reallocating, you say. You are asking reallocating, no? Where is the different variable name? Acha, why not different use name? Why same name? So the question is why somebody will use same variable and allocate the memory again and again. Yes, yes, come. You know array list in Java? Array list in Java. What's its size? Fixed or dynamic? As you go on inserting elements, it will. As you go on deleting the elements, this will happen internally. This will happen internally. And if you want the same thing in C program, you should do it. Reallocate and do it. Yes, yes, exactly. It will copy everything. Copy everything. That's why normal array is also there. You know that we don't go beyond this size. You use normal array. You're not sure. It may be growing and shrinking too frequently. Then go for array list. It is time consuming. Array list is time consuming. Suppose this class is not sufficient. We want a bigger class. So simply we cannot push the walls. We will vacate this class, we will shift there, everybody will go and sit there, then the class will start. Same way, you want a bigger array, all the elements are copied there. I'm just answering him. I have not raised the question, I'm answering him. Okay. So that's why in low voice I'm answering him. That's a different discussion because when you come across these things, you will get a lot of doubts, a lot of questions. So if you have questions after class, you can ask. I will not cover it as a topic. Okay, he got some question. I don't want to confuse you with his question and again answer it. So I was just replying him. Finished? So there are multiple gate questions upon memory leak. He gave the program code and asked options. Program work perfectly, program causes memory leak, like that. Options are there. All right. So, or it gives error. It will print 10, it will print 20, it will print 5, or give error. Like that, options are there. So they have given this is a key concept, you can say, upon which questions are asked. Memory leak. Okay. We'll see the questions. Just we are understanding the concept now. So what a program should have done? Program should have done here in normal syntax. Okay. P assign. Oh, sorry, not P assign. Free P, then do it. Then again free P, and again free P. So whenever it has finished using that, it should free that to avoid memory leak. To avoid memory leak. So what is the scenario? We are not looking into that. When it happens, when do you need it and all, we are not talking about that one. But this is required sometimes. Same pointer we use, again we allocate large memory or smaller memory. In this way we'll be changing. So we may have to delete the memory when it is not in use. So if you're not doing it also, one time also, you must delete it. Ho gaya. See, even when I was a student, my teacher told me that when you are creating a heap memory, you must delete it. And when I did some projects in C language and C++, I never bothered to delete it. I forgot delete him. So it was carelessness, right? Suppose I was doing some serious project, then develop a project for the client, submit it. Who will face the problem? Crash, crash. Who will face the problem? Client. So this was the common problem in C programming and C++ programming. The development part was very tough. If you have a beginner programmers or careless programmers, they may not delete. Then they started testing tools. That tool will tell you, you are not deleting, you are not deleting, you are not deleting. So many client has faced this problem, that poor software. One of the reason of poor software is memory leak, memory leak. Acha, have you ever faced a blue screen in Windows? One of the reason could be complete Windows hanged. How? One reason, maybe multiple reason, but one reason I am highlighting. Maybe this could be a reason because they could not figure out why their Windows hangs, right? So this could be one more reason. All right, because system itself is hanging. Though no heap memory, somebody has consumed its own system calls or its own system routines have consumed it. Don't know where the bug is lying. So program crashes, suddenly program crashes. Leakage, 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 leakage. There is no heap. We cannot move further. Crash. Understood this one? Chalo. Now, further. Problems using pointers. There are gate questions upon these concepts. There are three problems. One is uninitialized pointer. Uninitialized pointer, memory leak, and dangling pointer. These are the possible problems using pointers. So as a programmer, if you are using C++, then you must be careful with these three problems because without pointer, you cannot develop the applications also. Yes, Keshav, I'll come to that. That's my next topic. All right. Now, what these problems are, let us look at them. I will write down simple piece of code just to understand the concept, right? And even gate questions are also given using simple piece of code only, not lengthy code. Main function. In this, I have a pointer. Now, star p assign 5. Print star p. What is the problem in the code? I have a pointer. I have a pointer. Then at that address, I have stored value 5. Then I'm printing 5. Everything seems perfect. But there's a problem. Where that pointer is pointing. Where the pointer is pointing. Either you say main integer star p, or you have one more variable a, then you say p assign ampersand a, then you say star p assign 5, then you print star p. So these two lines are missing in that one. Oh, sorry. These two lines are missing in that one. Next. Otherwise, you should have done it like this. Main integer star p assign new just one integer. We don't want array. Then star p assign 5. Then print star p. Either this or this I should have done. Means what? P is pointing on some existing variable or memory inside the stack only, or it is pointing the memory in the heap. Usually pointers are used for heap only, but you can make them point anywhere. So we can make them point on some existing variable also, or you can make them point on heap. I should have allocated the memory. I should have allocated the memory. So this part was missing in this one. So this pointer, okay, you remember? Just recall. What do you call to this line? No, this line. Declaration. What do you call to this line? Initialization. So what is happening here? Declaration as well as initialization. So what is missing here? All right. Got it? Understood? Now, yeah, I'll come. I'm coming to that. I'm coming to that. Will it give error when you compile? No. C compiler will not say you have not initialized. Java compiler will do that in some cases using uninitialized variable. Right? If you have used Java, it will not allow you to use the variable without initializing them. But C++ doesn't say any, sorry, C++ doesn't say anything because the variables may have garbage value also. It will keep quiet. You know better why I should interfere. That's how it thinks. So it will not give a compiler error. But runtime error, what happens? It is a pointer variable. So every variable have some garbage value. So it is also having some garbage value, but that value is that value is not data, that is a address. Follow this one. So it's having some garbage address. When you say star p assign 5, it will go and store the address in that particular address. It will store 5 in that particular address. All right. Then print p. It will also print. If that address by chance belongs to within the Context of a program, by chance, if that is within the context of a program, then no error. Otherwise, outside the context means that memory doesn't belong to us. Listen, 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 listen. Right? Interesting analogy is coming next. So, does it belong to your program? So, it will cause runtime error, and runtime error means car suddenly stopped, crash. So, your program will also crash, stop suddenly. Understood this one? Now, listen, analogy. I got a key. This belongs to this door. Open. They will hold me and beat me. By chance, it was my own room. Safe. Own room, safe. Otherwise, I'll get kicks. Are you getting me? So pointer is like a key. It's not actual data. It's key to the data. You got a key and you're using it. I got a key of a bike. I'm opening it. So owner will beat me. No, no, it was my bike only. One among my bikes. Okay, no problem. Got the idea now? So what are more chances now? See, there is a chance of this one also, this one also. How much percent we can't say? 50-50 also you can say. But there is a chance of error, right? So we say error, error. If there is a 1% chance of error also, we say it's a error. So we don't say that if it is belonging to our program, no error, we don't say. We say it doesn't belong to our program, it's an error. That's it. So uninitialized pointer is a error. And this is the example syntax of uninitialized pointer, using a pointer without assigning it to some valid memory. Using a pointer without initializing it to some valid memory. What is valid memory? Either point to a variable or either take the heap memory. Then you store the value. Over. So gate questions are there. You will come across gate questions later on. You can answer them easily. I don't have to give you sample here. Void pointer. Ha ha ha. No, while is not a pointer. No? Pointer is a variable which will have its data type and name. Yeah, yeah, yeah. While is not a pointer, I am saying. You tell the syntax. WIDE you are saying. Acha, 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 okay. Ah, sorry. I first heard it as while. Yeah, it's a while pointer. You can use the term while pointer. While means we don't know where it will go. Uninitialized pointer is a while pointer. It's not under your control. Over. Now, this is over. Now, next is memory leak. Memory leak. You already know about memory leak. Already I have explained you. Memory leak is what? Whenever a program is allocating the heap memory, it should releases when it's not using. If it is not releasing, but keep on allocating the memory like this, then slowly the memory is unused and also it's not available, right? So it's not in use. So it may cause leakage of the memory. At one stage, there is no heap memory at all, and the program will crash. All right, all right, got it. So this was a common problem. So programmers do these two type of mistake. Third one I'll come to it next. Okay, but programmer will do these three type of mistakes. So among these two, now memory leak, we will talk little bit more, little bit more. Okay, memory leak. Let us come to that same analogy. I am a sports in charge. You are taking a football from me and you are playing and you are leaving it somewhere and you are not returning back. And again, taking a football because you forgot where it is. And you even forgot that you have taken and you have played for a while. Again, you came freshly and taking a football. I am in charge. If I keep quiet, then all the balls will be gone. All footballs will be gone. So what I do is, after every few minutes or half an hour, 1 hour, I'll take a round, look into the ground. Any balls are lying here and there, I'll collect them and bring them back to the sports room. You have not returned. I'm taking it back. I'm taking it back. Garbage collecting. Garbage collecting. All right. Do you agree with this? Have you heard this term anywhere? Where? Python as well as, yeah, Python also it's there. It's there in Java also. In Java, you don't have anything like delete or you don't have anything like free. Java say that you take the football, sir, I will return it. No, no, don't return it. I'll collect it. Okay? Java says that. In Java, new is there. New. New is there. But free delete is not there. New means, okay, take this, take this. So it will keep watching. This ball nobody is using, it will take it back. This one nobody is using, it will take it back. So if memory, heap memory, nobody is referring there, it will take away the memory. So no reference is there, it will take away the memory. So that is done by the garbage collector, and it is called as a daemon process, which works in the background. After every while, it will wake up and check, is there any memory which is unused, it will take it back. All right. So that when again the program needs, it will allocate the memory. So there is actually internal some mechanism is there in our program which takes the responsibility of giving the heap to you. All right. So we should return it back. Some sports in charge is there. So whenever you write a C program, C++ program, that program in the machine code automatically that in charge will be added. You are not dealing with that one. It is added. So when you say new, it will give you the memory. When you say free, it will take the memory. So there is some module added in the program, in the machine code. So otherwise, from whom you are taking, to whom you are giving, not to the operating system, within your program only. All right? Understood this one? So Java is also having the same thing, memory allocator and garbage collector. It will take the memory. In Python also, there is no free, there is no new. But memory is allocated, not used, it will take away the memory. So that's the garbage concept of garbage collection. Memory leakage is there. Okay? So if you don't deallocate the memory, it causes. Now I have to explain this one. Which one? No, at one stage program may crash if there is no sufficient heap memory. Okay? This uninitialized pointer, the moment you access, it will crash. So it is sudden crash. Memory leak, slow crash. Leakage, 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 leakage. There is no memory at all. So slow crash. But okay. Anyway, now next one, dangling pointer. I am showing you the sample code. Sample code. Oh, here. Through the code, I will. Oh, sorry, sorry. अरे तो Main. Watch this. Watch this. I have a pointer P. Okay. And P assign new int of size 5. Hmm? Then after some time, I have a pointer Q also. And Q assign P. And after some time, Q free Q. And after some time, you want to print star P. I have to, I need a space for explanation also. Sure. Is it enough? There's font size? Sure. Sure. Watch this. I'm explaining you this. I have a pointer P, which has created the memory of size 5 in heap. Then after that one, it has used and one more pointer came, that is Q, which is also pointing on this one. P has given the address to Q also. Okay. Why you don't ask? Okay. Why it is doing that? Don't ask. This is required in your program. This is happening in your program. Then after some time, Q has freed the memory. And P is trying to access the memory. Is it there? No. Memory is not there. It's already freed. So what happens to the program? Program will crash. It is just like now, but it is not uninitialized. It was already initialized, but that somebody, some other way, it was deleted. So now P is still pointing to the same memory, which is no more allocated to the program or function program, let us say. So this is called as which pointer? Dangling pointer. Okay. Now wait. Dangling pointer. Now wait. Mr. P bought a car. With car, you get two keys. Mr. P's friend is Mr. Q. And he said that he is my best friend. Let him also use the car. One key he has given to him. So P is also using the car. Q is also using the car whenever it is free. Now, at one time, Mr. Q thought that I need some money and sold a car. Now, Mr. P is just having a key. And that is a dangling key. He's thinking that car is there, but car is gone already. All right. So this is not a wild key, like you use the word wild. It's not a wild key. It was already allocated. So it's a dangling key now. It's a dangling key. So we use the word dangling pointer. Understood? Dangling pointer. Now, understood this one? Now watch this. Now watch this. Main. This syntax is sufficient for understanding the problem. Okay. Now I'll give you one scenario. Watch this. Where it may happen. Now I have a pointer P, and this P is having a new memory, integer of size 5, and it is calling a function fun and passing P, and this function fun is taking a pointer int star Q. And you are a good programmer, you know that whenever you don't need the memory, you should say delete Q, you have deleted, and when you come back, function main allocated the memory. Function main given the pointer to another function fun, and that fun has deleted the memory, and main doesn't know that. Main doesn't know that. When you come back, and main will try to use that one. So memory is already gone. So entire thing, who wrote? I have written it. Here, as a very good programmer, I am deleting the heap memory every time. So deleting is also a problem. Not deleting is also a problem. Deleting carelessly is also a problem. Not deleting carelessly is also a problem. So that's why Java, Python, they started giving garbage collector. If you delete also, it's a problem. If you don't delete also, is a problem. Just you keep quiet. You don't have delete at all. Delete at all. We will take away the unused memory. Understood? Are you getting me? Understood? So who did this mistake? I have done this mistake as a programmer. This is my program only. Huh. P is there in main. Memory is created. Okay, heap memory. And pointer P is given to another function fun. And it has taken in Q. And the P function fun has used that heap memory, and at the end it has deleted that heap memory in the queue. So I have written the same code, entire code in the same function, but I have distributed over the function. So this may happen. This may happen. All right, understood? No, no. Free is used for going to the address where that pointer is pointing and removing that memory, freeing the memory. Not reference is not made as null. It remains the same address. It will have the same address. Deleted, deleted. No, no. Memory is deallocated. In the records, it's returned. Football taken, football returned. In the records, it is removed. You are talking about clearing the memory. Not clear. It's not belonging to the program now. Hmm. It will also have the same address. You have to make it null. You have to make it null. You have to make the pointers null. I am not writing that. You have to make it null. Understood this one? So just this piece of code is enough. P allocated the memory, given the address to Q also. But who should delete? Using P only, we should have deleted. Using Q, we deleted. And now we forgot that actually the memory was allocated by P, and we are thinking that P is still there. See, actually, I'll show you the scenario, the actual problem. You have done programming. You start writing the program. Int A, B, C, D, and A assign 5, B assign 10, something, and you start writing the code. What was there in A? Scroll up. A was a 5. You will forget the things by the time when you reach writing the code. Same thing is happening here by mistake. So documentation is important. Still, there may be a chance of mistake. So these are not intentional mistakes. These are careless, or you're not careful. So these mistakes are happening by yourself only. You are a programmer. Main also you have written it, and function fun also you have written it. Understood? But you have not seen it carefully that where you are going wrong. And this could be a mistake happened by you that may cause problem at runtime at the client side. Understood this thing? So there are three type of problem that are caused by pointers. Hmm. Are you using to again same thing only? Same thing only. Same thing only. Same thing. That is also dangling pointer. Yes, correct. Whichever one, but I made it as a story that one pointer allocated, another pointer deleted. I made it as a story like this. So where it is possible, here I have shown you. You have given to some other function. Function deleted. When you come back, you are thinking, actually, I have created it. Why you deleted? New was here, na? Delete should also be here. But some other function has deleted. That type of mistake, you may be doing it. See, lastly, one thing I have told. Have you understood the concept? Concepts have you understood? Hmm. Code is not important. For explanation, I cannot give you, or we cannot give you entire scenario and show you that this is the problem. Just with the 2-3 lines only, concept is understood. Okay? Don't think why P, why Q again, why function. Don't think those things. All right? Just 2 lines only. And even when you say gate questions, in 2-3 lines only, they will ask the questions. All these questions are very small questions. Not a lengthy code in that find out where is memory leak. No, no. All right. because this happens in a very big application. This type of problem arises in big application. So we cannot draw a big application and understand it. At a small stage, just we are writing some sample code and understanding. Is it clear to you now? Just in 2 3 lines we will understand. Over. So pointer has already allocated the memory and still pointing there, but some other way the memory was deleted. So pointer is still pointing there. And that is called as a dangling pointer. So in simple words, pointer is pointing on the memory which is already deallocated. How it is deallocated and all, leave it. Pointer is still pointing on the memory which is already deallocated. So it's a dangling pointer. If you try to use it, it's an error. If you're not using, no problem. Not using it, no problem. Finish, no? Now I am writing a piece of code. When I say answer, then only you should answer it. When I say answer, then only you should answer it. Okay, I'll write the code and ask a question. Then when I say answer, then only you should answer it. See, main, I'm writing a function fun, which is returning a pointer of type integer, integer x assign 5, x plus plus, a return ampersand x. Integer star p, call function fun, and take the result in p. I will explain you the code, okay? Syntax, you don't worry. Then print star p. Watch here. There is a function fun having one variable called x, which is having value 5, x plus plus, it becomes 6. Then it is storing ampersand, sorry, it is returning ampersand x, means it is returning the address of the variable x. Address of the variable x. And so return type, I have made it as int star. This may be a new syntax for you. I'm explaining everything. Okay. So star. So it will return the address. Now, if you come to main, it is having a pointer p and it is calling function fun. Whatever the address written by that function is taken in p, then it is trying to print the value at that particular address. This is the code explanation. Once again, there is a function is having a variable 5 which is incrementing, so it will become 6 and it will return the address. This main function is calling the function and taking its address in p and trying to print the value. Okay, explain the code. Now the question is, which type of 3 problem is there? You should not answer quickly. You should not answer quickly. 3 problems we saw just now. Which type of problem is there in this piece of code? When I say answer, then only you should answer it. This is a part of gate question. Means similar type of code they have given. Answer. Very good. Dangling pointer. How? Function fun is having variable x, its own variable inside the stack. When it ends, its variable is deleted, and but it has given the address. Means I sold my house and gave you the key and said that you can use my house whenever you want. I am going on vacation. Sold the house and given a key to you. Sold the car and given a key to you, just like that. So when you try to access, it's an error. It's an error. Understood? So this is an example of dangling pointer. Okay. If you can hold for a while, one more answer you give me, it's a quick answer, then you can copy both piece of code. Main integer star p. When I say answer, then only you should answer it. P assign. new int of size 5, p assign. When I say answer, then only you answer it. Answer it. Come on, very few answers. Memory leak. I allocated the memory, I turned back null. Null means not pointer. Are what happened to the memory? You should have deleted that now. So simply made null without freeing the memory. So this is memory leak. This is dangling pointer. This is memory leak. Any questions from online students? Yeah, garbage collection. Keshav, I have explained about that one. Uh, no, I have not written any book. I'm very lazy person. I don't have that much time. When p is passed to a function, how does the program flow works? P is passed to a function. Yeah, from the main function, fun is called, and the address that is there in p is passed. So actually, we have not seen parameter passing methods. I am discussing about the pointers. So you have to adjust with the syntax. So that's why I'm explaining it clearly. That's why I'm explaining it clearly. If you are not familiar with the syntax, don't worry. What all I have explained, you take that much only. That much only. From here, previous one, so like P was passed and it was taking in Q. Varun has asked the question. I think his name is Varun only. We have not seen parameter passing methods. We are looking at the problem caused by pointers. Okay, that is the topic we are discussing. See, you will have topics in different pieces. Different type of topics you have under pointers. So there is no flow, step by step building is not there. Different variety of topics are there under pointers. One time you saw array, one time you saw new, the other time you are looking at problems. Okay, there are more things to come under pointers. More things to come. Finished? Now, watch this. I'll tell you the topic later. First, I'll explain. So we'll discuss actually. Watch here. Integer P1. Sorry. Integer star P1. Which type of pointer? Integer type of pointer. Float star P2. Float pointer. Char star P3. Character pointer. Void star P4. You can have a pointer of type void also. What is the use? We'll see later. Void also. 4 point. Size. How many bytes? Integer we are saying 2. So pointer also we will say 2. All pointer take same size of memory independent of their data type, because the pointers are meant for storing addresses, and addresses are unsigned integer. And in the beginning I have shown you that we will be considering the memory from 0 to 64 kilobytes. For that you need how many bytes? That time only you decided you need 16-bit, that is 2 bytes. Okay, but on 32-bit machines pointer takes 4 bytes, and latest compiler pointers are taking 8 bytes. So that is not a concern with the gate. In interviews and all, you may have to answer based on the current compiler that you have used, but in gate, the size is not important. Size is not important. If they have to mention, they will mention the size. If it is important, they will assume that the pointer is taking 4 bytes. They will say 2 bytes or 8 bytes. They will say that. Okay. But as per our discussion, we should decide some size. So I have taken the pointer size as 2. So the important thing what you learn here is whatever the data type is, pointer takes 2 bytes only. Pointer takes 2 bytes only. Size of the pointer. This is the topic. Size of the pointer. And what we learn, every pointer takes same amount of memory. Whether you say 2 for all or 4 for all or 8 for all, that is a choice. Then one question that may be around, why data type, sir? That's our next topic. No, we don't have to write anything signed unsigned. No, you know that pointers will store the addresses. Addresses are unsigned integer. There are no negative addresses. Then a pointer will be unsigned only. Don't look at this. Just star means 2 bytes. Star means 2 bytes. Star means 2 bytes. Whatever the star may be. Whatever the data type may be. Not end, float, char, anything. Whatever the data type may be, pointer takes 2 bytes, same size, because it will store the address. And for storing the address, the size depends on the size of the pointer, depends on the size of the memory. So we assume 64 kilobytes in our discussion. So 2 bytes, we are saying. Okay. Now the question is, why pointer have data types? Okay. Now, for that, this was the size. Later on, I have written the topic heading. Now I'm writing new thing, explaining something. Then I will write on the heading. Okay. Watch here. Watch here. Integer star p assign. Oh, okay. Assign new integer. Okay. So p is assigned with a new integer. Listen carefully. So integer means how many bytes we are assuming? 2 bytes. 2 bytes. So let us say this address is 200 and this is 201. Small addresses I have written. Now one thing important. Pointer will have which address? First byte's address. Then how it will access second byte? Plus 1, next address it will take. So always pointer can store address of only 1 byte. So it will store the address of first byte. I'll show you example. This bench is there. I want to move. Base address I am holding, I am moving the whole bench. So I can access the entire bench by using its base address. So same way, the entire array you can access using a base address. Understood this one? Okay. So you can next address it will take and it will access. Over. Now watch here. Watch here. Next. I am writing something, discussing with you. Okay. So you are involved, very much involved here. Next. I will say star PO, yellow color I should take. If I say star P assign 100, I'll take a bigger value, more than 256. 321, one value I will take. Some number I have taken. I have taken this one. Listen carefully. All right. Now, in this, somehow 321 is stored. 321 stored. Now watch. I have a character type pointer Q. Then I will say Q assign char type of pointer with P. So I have a Q also. which is pointing on this one. So it's also having the address that is 200 to the same memory. How many bytes of memory? 2 bytes. Who is pointing? P. Who is pointing? Q. Now comes the important thing. Now comes the important thing. When I say printf percentile D star P. So I am saying I want to print the data. Which data? Wherever P is pointing. So means go to P, take the address, go there and read the data. So what's the value? Wait, wait. P is going there and reading how many bytes? Why? Who told P that to read 2 bytes? Because P is, no, P is integer type. P is integer type. Wait a minute, hold. If I say print f percentile C to the same memory star Q, it will go there and read only 1 byte. What you will get? Don't know. You want to print it as a character, so you will get some character. Don't know what you will get. Because it's not reading complete 321. 321 is written in 2 bytes. So it's reading just 1 byte. Don't know what value it get. Okay. Something you get here. Understood here? We are not concerned what it will print. The important thing is what? It will go there and access. Come on. It will go there and access only 1 byte. It will go there and access 2 byte. 2 byte. Now one more. I'll continue here. I have a float type of pointer star p2, and to that I will assign float p. Then I will say printf, sorry, percentile f star p2. So you have a P2 also now. You have a P2 also now. And in that, this is also pointing there, right? You brought all of them and they are pointing there only 200. Now, will it go there and access or not? Yes. But how many bytes it will access? 4. But actually to your program, how many bytes you belong? 2. Other 2 are? Other 2 are? Do they belong to our program? What causes here? What happens here in this line? Anything printed? Again. I'm asking. You can answer it. You can listen carefully. Listen carefully. P2 is pointing here, same location, but only 2 bytes belong to a program. But when you derefer P2, it will go there and try to access 4 bytes. You know this well. Now my question is, other 2 bytes doesn't belong to your program. So what happens in this line? Will it print or 2 bytes doesn't belong to your program means what was happening just now in previous slides? Dangling, program was crashing. Yes, error, crash. Okay. Uh-huh. Uh. And then you have to check it. You have to check it. It will be printing character, but which character you have to check it. 2 byte only. 2 byte only. I'll explain. I'll explain. Understood till here? See, what was the discussion? Once again, I am showing you. You have a pointer P and allocated integer 2 bytes. But when you assign a pointer Q, it will go there and access 1. Using P, if you access, it will access 2 bytes. Using Q, if you access, it will access 1 byte. Using P2, if you access, it will try to access 4 bytes. So the point is, When you dereference a pointer, pointer will go to the base address and access how much memory? Depending on its data type. Depending on its data type. So this is the discussion. Once again, whenever you derefer a pointer, it will go to that address and access the number of bytes equal to its data type. Now the question is, why pointers will have data type? Hard to access the memory. This is one of the reason of data type. Otherwise, they store address only. Na? Why you have int pointer like separate float pointer like again char pointer? The reason is char pointer will derefer. When you derefer, it will access only 1 byte. When float pointer, when you derefer, it will access 4 byte. Char integer pointer, when you derefer, it will access only 2 bytes. So once again, I am repeating. When you derefer a pointer, it will access number of bytes depending on its data type. Okay. What will be printed? We are not concerned about that. Okay. Understood this one or not? So what I have given you the example, to the same address, 3 pointers are pointing, character also, integer also, float also. If you derefer, it will go there and access 2 bytes. If you derefer this, it will access only 1 byte. If you derefer, it will access 4 byte. Understood this one? So what was the actual discussion? Why pointers have data type? Answer is, when you derefer them, they will access the number of bytes depending on their data type. Any question? हाँ, 1 byte, 1 byte, 1 byte. एक मिनट. We are not concerned about this. That's all. I should write down here 2 bytes, 1 byte, 4 bytes. Are you getting me? What's the point here? When you derefer a pointer star p, it will access 2 bytes. I'm not concerned. I don't want to show you what will be the output. I think you are lost in the output. Even I don't know the output. You write on the program and check it. Okay. If you want to see the output, write it and check it. We are not talking about what is the output. Just as you are aware, so I asked whether it gives an error or what. I asked you. Understood this one? Uh, Here also, float star. You should typecast a pointer and assign it. Typecast. See, P is a integer type pointer. You should typecast it and assign it to. No. I told you already before taking break. I told you in some compilers, some versions, it may implicitly doing it. Otherwise, you must write it. So good thing is you write it. Type conversion you should do for the pointers also. So only the thing is, the topic is what? Why pointers have data type. Answer is what? When you derefer a pointer, it will access the number of bytes depending on its data type. Depending on its data type. That's it. Okay? That's it. Nothing more. Danish, what is your question? You tell me. So in the previous question in query, okay. Previous question, since x is a stack variable, it's memory, then when the function ends. Acha, okay. Varun was asking a question. When the function ends, it's yeah, dangling point. Okay, you have given the answer. Now where Danish got confused, just 1 minute back you got confused. So what was your question? Can you tell me? This is a fresh topic. On the top, I have written the topic. In the previous slide, I have told you every pointer takes same amount of memory. Ha. Every pointer memory, it will take 2 bytes. Yeah. Danish, I said that pointer amount of memory takes same. I think you join in between the class. Were you there in the beginning? See, when you declare a pointer star p, then it will also occupy the memory in the activation record, and it will store the address. It will also have its own address. So this memory consumed by this one. So this memory, we are talking about this memory, 2 bytes, 2 bytes, 2 bytes. P also 2 bytes, Q also 2 bytes, P2 also Q bytes. But when you say new int, integer is 2 bytes. Hmm. Hmm. एरर आएगा, यहाँ एरर आएगा क्योंकि 2 बाइट्स एक्स्ट्रा है ना। अगर वो 2 बाइट आपके प्रोग्राम को बिलोंग करते हैं तो एरर नहीं आएगा, नहीं तो एरर आएगा। तो हम ये मान के चलेंगे कि एरर आएगा। यस यस, आउटसाइड द मेमोरी, आउटसाइड द कंटेक्स्ट ऑफ द प्रोग्राम हो सकता है, कुछ भी हो सकता है। गार्बेज आएगा, गार्बेज आएगा, गार्बेज आएगा। अगर यहां पे तो क्या प्रिंट हुआ था, व्हाट वाज प्रिंटेड, 320, एंड हियर इट विल प्रिंट ए, it will print a. What is that, how, separate topic afterwards, after some topics will come to that, not now. So we are not concerned what it will print again. We are concerned how many bytes it will access. Watch here, watch here. Integer, the point what I am trying to convey, that is more important. You have a pointer p1, and to this you have assigned new int of size 20. So P1 is pointing on an array, sorry, P1 is pointing on an array of size. P1 is pointing on array of size 20. So 20 what? Sorry. Wait a minute. Wait a minute. Wait a minute. I wrote a minute. Char. 20 what? Characters. P1 is which type of pointer? Character. So it's pointing an array of size 20 characters. So how much memory? 20 bytes. 20 bytes. Eh? Now watch. Same thing. I'm taking another example explaining. Integer star P2 assign P1 but typecast it as integer P2. P2 is a pointer which is taking the address from P1 typecasted as integer type. So P2 is pointing on that at 20 bytes. So it's an array of size. No, P2 is pointing on this 20 bytes. 20 bytes. But P2 is which type? So 20 bytes makes how many integers? 2 bytes for 10. 10. Array of uh, I'll do like this. This was array of char of size 20. Array of int of size 10. Do you agree with this now? Next, float star p to assign float star p1. So same address of p1 is given to p1 is also given to p3 star p3. See, float type pointer p3, same address p1 is given to this one. So you have one more pointer p3 pointing to this one. Now total how many bytes are these? 20. Float takes 4 bytes. So float type of pointer is pointing means it's an array of size 5. Array, so array of float of size 5. Now you understood? 20 bytes. Character pointer pointing, it think as array of size 20 characters. Integer pointer pointing, it will think it as array of size 10 integers. Float pointer pointing, it will think it as 5 floats. Same memory, pointer change, perspective change. Understood? So data type of a pointer is not for its own size. This doesn't mean it's a size. Every pointer take 2 bytes only. Every pointer take 2 bytes only. Because pointer will point on the memory, right? But when you use a pointer, derefer it, it will access the amount of memory depending on its data type. Okay? Now, one thing. I'll give you an analogy so that you can remember it. And if you have any doubt, you can clear it. Listen. Bicycle key, bike key, house key, right? Car key, aeroplane's key, all keys of same size only. Aeroplane key bigger, ship's key more bigger. No, all keys are of same size. So pointer is a key. Pointer is a key. So all pointers are of same size. Every pointer takes 2 bytes only because it has to store the address. Store the address. Understood? This key belongs to car, so it will open car only. This key belongs to bicycle, it will open bicycle only. If you take the key of a bike and put it on a ship, key will think that it's a bike because key belongs to bike. It will not see what is there. Wherever you are inserting, it will think that, okay, it's a bike. All right, understood now? Understood now? What the analogy? So when you're using, means key will not think, you are inserting a bicycle key in the door to open your door. So you are thinking your home as a bicycle because the key is bicycle key. Arey, this is door, this is not bicycle. So what is important? Object is important or the reference that you are holding is important? A reference is important. In this case, in C++ perspective, C++ perspective, reference is important. What the key that you have. So if you have a bicycle key, in whichever hole you are inserting, that is a bicycle's lock hole. Okay? So, in this picture you have that. 20 bytes. You have a bicycle pointer. So you'll think that 20 bicycles are there. You have a bike pointer. So you think that there are 10 bikes. You have a car pointer. You think that there are 5 cars. Space is same, but the perspective change depending on the pointer. Understood now? Is it clear? With this analogy, you can remember and recall also. You can easily recall also. Is it clear, Danish? Yeah, that's great. That's great. Over. Now, more we have to discuss about pointer, and the point topics are not related. Independent topics are there. Otherwise, there should be some flow. After this, build up. So I cannot build up this one. All independent topics are there. Now, the next thing is we have to learn how we can use pointer for accessing an array. And there is one more reason why pointers have uh, data type, that is pointer arithmetic. We will learn these two. So also we'll learn about array, then we'll solve some gate questions. So tomorrow we will solve gate questions. Otherwise, after that we will solve some gate questions. This topic is lengthy, and just you're learning concepts. And the thing is, syntax only you're learning, nothing else. Syntax is little bit only. Syntax is little bit. So in this entire discussion, today's discussion, if you start from the beginning, let us wind it up here, because if I start, it will take time. I cannot stop in the middle. See, you have seen what is declaration of a pointer, initialization, and dereferencing. So for declaration, you have to write star. For initialization, you don't use it. And when you're dereferencing, you should write star. And pointer is also a variable. Just like data variable, pointer is also an address variable. So data variables are used for storing the data, pointer variables are used for storing the addresses we have seen. And as data variable will have its address, when you say ampersand, will get its address. Pointer will also have a address. When you say ampersand p, you will get its address. All right, because it's a variable only, but not for storing the data, but for storing the address of the data. Then I have shown you what are the uses of pointer: dynamic memory allocation, parameter passing, pointer arithmetic, and accessing resources. Then I have shown you what does it mean by accessing resources. All other things outside the context of a program are the resources. And I have shown you the discipline of using a resource. Whenever you want a resource, take a resource. When you don't want, you should release it, whether it may be a file, whether it may be a connection, socket connection. If you have done socket programming, you might have seen that you will say new socket. When you don't want, you will say socket.close. In Java, if you have done it. And file handling, when you open a file, when you don't want, you say file.close. Right? You will release it. And there is a special method in Java for deallocating the resources by itself. Automatically, it will deallocate the resources, whatever you are using inside the block. So handling resources is a very big issue in programming. So heap is also a resource. Heap is also a resource. So that is also precious. An external thing. So when you are taking it, you should say new. When you don't want it, you should say release. That is very important. So I have shown you that in Java also you have references that are nothing but the address variable only, but they don't have star, all these things. So they said that we don't have C style syntax. So they said that it's just a reference. We should not confuse with the pointer. Like suppose Java people have said that Java is also having pointer. You will say, where is the address? Where is the address? Because you are coming from C programmer. Most of the Java programmer were coming from C++ programming. So they did a good thing that they have changed the name and set reference. We don't have pointers. They were very happy. So, but pointer is there. Self-managed pointers are there. Self-managed pointers are there. In C language, C++, you should manage them. New, delete, dangling pointer, all this headache. There's not there in Java. Anyway, then I have shown you that, yeah, new and malloc are the two methods for allocating the memory in the heap. Whenever you say just a variable, it's in stack. When you say new, then you get memory in heap. You will not get the memory in heap unless you say new or malloc. That is the only way. And for that, you need a pointer. So that's why we use a pointer. Then what I have shown you is when you are allocating the memory in the heap using a pointer, then how you can access it just like it's an array. Just like it's an array. The next thing I have shown you that here I have shown you that whenever you are allocating a heap, allocating the memory from heap and not using it, you should delete it. I have explained about the memory leak. And I have discussed about three type of problems using pointer: uninitialized pointer, memory leak, and dangling pointer. Right? Uninitialized means you have a pointer, you have not initialized, but you are using it before initialization. Dangling pointer means you initialize, it was already pointing, but now the memory is no more allocated. Memory is gone. And memory leak means you are not releasing the memory. At one stage, your program may crash. Here the program suddenly crash, here also suddenly crash. This may cause slow crashing, memory leak. All right. But most commonly faced problem is memory leak. Sudden crash, I am writing the program, there only I will get the error. I'll stop. Oh, I'll correct it. Memory leak, it will cause slowly means it will cause at client's end. You are buying a car from the bike from the showroom, there itself it's not starting. It's not us. They will change it. After running for 1000, 1500 kilometers, giving problem means. So memory leak is that type of problem. So the most commonly faced problem in the software industry, in the history of software industry, is memory leak problem or pointer related problem, you can say. Next is, I have given you the example and asked you to identify which one is memory leak, which one is dangling pointer. Then I have explained you that all the pointer take, whatever the data type of a pointer is, the memory consumer, the pointer is 2 bytes only. The next I have shown you why a pointer have a data type, because not for its size, but for rereferencing. When you derefer, it will go there and access the number of bytes depending on its data type. So character pointer will access 1 byte, integer pointer will access 2 byte, and float pointer will access 4 byte. Whatever the data may be, whatever the memory belonging to the program may be, they don't see that. So you are responsible for making them point and access them. Okay. So just for explanation, I wrote this, but as you got some confused, so I have just given one more example that allocated a 20 characters, then assigned to pointer integer type. So it will think 10 integers, then it will think 5 floats. That's all. So more to come. Pointer arithmetic we have to see, then pointer to an array, then pointer to a function, parameter passing. All these topics will cover. Hmm. Did you enjoy the topic, or for 3 hours pointer headache? That's great. Keshav, if you are planning, we will write a book. That's great, Diksha, Aradhna, Varun. Thank you. Good night. See you tomorrow. Mohanta, Abhilash. That's great. Thank you. हाँ बंद कर देना. We are closing online session. Right. Thank you. Thank you for all.